SpaceX confirms its Falcon 9 rocket is cleared to return to flight, Boeing's Starliner is set to perform a critical hot fire test while attached to the ISS that'll decide how Sunny and Butch return from orbit, the rocket that'll take humanity back to the moon arrives at the Kennedy Space Center, and NASA's Perseverance rover has us wondering, was there ever life on Mars? There's all that and more coming up this week in Spaceflight. NASA astronauts Sunita Williams and Butch Wilmore have been in orbit for about 51 days, and during that time, they've been waiting for NASA and Boeing to clear their Starliner spacecraft to return them back home. Both parties have been busy trying to characterize thruster issues and helium leaks that appeared on the spacecraft while on its way to the ISS. This involved a series of hot firing tests at the White Sands Missile Range, where one of the thrusters that was earmarked for a future flight was put through its paces. We talked about that testing on last week's episode, so check that out for more information. This week, NASA and Boeing talked about the results of said testing and what's coming up next. But spoiler alert, we still have no news on when Starliner will return. What's more, we don't even know whether Sunny and Butch will actually come back on Starliner at all, but we'll get to that later in the story. So with all of the ground testing, what else have they found? Well, teams on the ground were able to replicate the thruster degradation and issues that were seen during Starliner's flight to the ISS. Teams put this thruster through a set of firing simulating 2 uphill trips to the ISS and 5 downhill return trips from the station. They also concluded that manually flying Starliner seems to put more strain on these thrusters and thus will not be using that capability for whenever the Starliner spacecraft does indeed come home. Also at White Sands, teams were able to test the service module that was originally going to fly on the Orbital Flight Test 2 mission back in 2021. Now, in case you don't remember, this service module was found to have corrosion on its valves and was forced to delay by a whole year, with a different service module being used for that mission instead. This service module has since been fueled and has been sitting at White Sands for almost the entirety of the past 3 years, so teams were able to use it to characterize helium leakage in a worst-case scenario. This is because, after years of corrosion, the seals have degraded to the point of essentially being at their worst condition. In order to validate all of these findings and testing on the ground, this weekend, teams will perform 2 crucial tests while docked to the ISS. NASA's Steve Stitch nicely summarized this during the press conference.
The next thing we want to go do is a docked hot fire test. And that should happen this weekend. So at ISS, what we're going to do is we're going to fire 27 of the thrusters. We're not going to fire the one aft thruster on the bottom doghouse. It's called B1A3. That's the one that has really low thrust. So we're going to fire all those thrusters to a number of pulses just to make sure before we undock that whole system performs the way we expected and the way it did last time we checked it. We'll also get a chance to look at the helium system. It's been 6 weeks since we last checked that helium system. That was on June 15th. So we'll pressurize manifold by manifold and then hot fire the thrusters, and then we'll get a chance to look at the helium leak rates and verify that the system is stable.
Steve also later mentioned that going forward, this hot firing testing will be performed on all future Starliner missions before committing to undocking. Apparently, this is something often done for Soyuz and Dragon, but was never contemplated for Starliner. Now it'll be something routine going forward. He also explained that while teams used the old service module for OFT-2 with severe corrosion, the source of the helium leaks on the Starliner in orbit is of a different nature.
As you get heat into the thruster at certain pressures, that vapor, the oxidizer will vaporize and become a gas, and it becomes very hot, and it causes this seal to swell, and that's a different problem than what we had in 2021. And so we didn't see any likelihood of this happening at all in 2021. So there was we should have done a major redesign of the hardware because we didn't know this problem existed in 2021.
Boeing and NASA will also meet over the next several days to complete the dissection of all of the thruster and helium leak data gathered at White Sands. This will culminate at the end of the month with an integrated data assessment meeting that will inform NASA leadership about the findings of this testing and the rationale going forward. If all goes well and the reviews are positive, this would then lead to both parties undergoing a readiness review in early August that would hopefully set a return date for Butch and Sunny. So once again, we'll have to wait just a few more weeks for that to be determined. But what if it's not favorable? Well, these reviews still do need to take place, but in the meantime, it appears that NASA has confirmed that they might, in theory, use SpaceX's Crew Dragon spacecraft to return Butch and Sunny home.
A luxury in our program today, and we've never really had this option in other NASA programs, is we have two different systems that we're flying. Obviously, the backup option is to use a different system. I would rather not go into all those details until we get to that time, if we ever get to that time, on what we plan to do. But the beauty of having Dragon and Starliner and two different diverse space transportation systems is we can kind of use those as backups. Someday Starliner could be a backup to a Dragon mission, and we've looked at all kinds of different contingencies for that. You've seen the Russians send up an empty Soyuz, right, to return a crew when they had a coolant leak. So I think the beauty of what we have in Commercial Crew is two different systems, and we would employ those systems if we need to, but we really have our team focused on, as we close in on this final flight rationale, returning Butch and Sunny on Starliner.
Heading all the way over to China, two separate companies are gearing up for high-altitude flights of their reusable first-stage prototype hoppers. First, we have Deep Blue Aerospace with their hopper prototype vehicle for its upcoming Nebula 1 rocket. This rocket is a partially reusable two-stage rocket with a 2-ton to low Earth orbit capacity fueled by kerosene. In some sense, it's like a mini Falcon 9 with 9 engines on its reusable first stage and 1 single engine on the second stage. This first stage will propulsively land, and in order to prepare for this, the company has been executing a series of hop tests with subscale test vehicles. Back in 2021, it completed a 100-meter hop test of the Nebula M hopper vehicle and was followed the year after with a 1-kilometer hop test of the same hopper, this one with a rather bumpy landing. Now the company is getting ready for a 10-kilometer hop test with a full-scale first stage of the Nebula 1 rocket. This included a short hot fire test of this hopper back in April, followed this week by a full-duration burn simulating ascent and descent. This also included what appeared to be a simulation of the release of landing legs by deploying a landing leg while on the test stand. Thankfully, this one didn't fly off unexpectedly. The 10-kilometer hop test could be within the next few months, so we'll keep an eye out for when that happens. It's bound to be very interesting. Much closer to a 10-kilometer hop is LandSpace, which is gearing up for a similar flight of its Zhuke 3 hopper vehicle. This company recently became the first to successfully fly a Methalox rocket into orbit with its Zhuke 2 rocket and has major plans to develop a partially reusable Methalox rocket, Zhuke 3. LandSpace already performed a hop test of this hopper test vehicle back in January, but back then the vehicle only performed a 100-meter hop. Since then, it's been refurbished and equipped with actuating grid fins that'll be used during this upcoming 10-kilometer hop. According to rumors on Chinese social media, this hop test could occur in the next few days, potentially even between the time of recording and publication of this video, so we'll definitely keep an eye out for when that happens. Both of these companies are aiming to debut their reusable rockets later this year, so a successful 10-kilometer hop test within the next few days or weeks will be crucial for them to demonstrate that they're on track to deliver as promised. The core stage of NASA's SLS rocket for the first human flight to the moon since 1972 has arrived at the Kennedy Space Center. Tucked on board the Pegasus transport barge, the Big Orange core stage arrived after an almost 2-week trip from the Michoud Assembly Facility in New Orleans, something that we talked about on last week's episode. This ginormous stage will be the one in charge to put the interim cryogenic propulsion stage and Orion for Artemis II on an orbit around the Earth prior to the trip to the moon. Now, this core stage in particular is special because of two different things. First of all, not all of its engines have flown before. If you remember, the first few RS-25 engines that powered the SLS core stage were all leftovers from the Space Shuttle program. However, 2 of the 4 engines on this particular stage were made from parts rather than refurbished engines. Also, this is going to be the last time we see one of these arriving at Florida with its 4 engines pre-installed. Starting with Core Stage 3, the tankage and engine section will be shipped to KSC separately and integrated within NASA's vehicle assembly building. So now that the Big Orange rocket is in the barn, what's next? Well, our own CAPE team was able to interview some of the officials involved in the program, including former NASA astronaut Doug Hurley, to talk all about the preparations for Artemis II.
Out in Utah, we are part of Northrop Grumman called Propulsion Systems. And so the cases themselves are existing shuttle heritage cases. And then out in our promontory facility, we pour the propellant, we mix the propellant, cast the propellant into the cases. There's insulation and other things, kind of lining. And then we've got 5 segments per booster. And then we've also got an aft skirt and a forward skirt and frustrum, the nose cone area. And then those cases, once they're fully cast, get put on a rail car and shipped to Florida. And you can see parts of them here and over there. And then ultimately, probably later this fall, all that will be moved over to the VAB and they'll be stacked vertically. And that's the first part of the SLS stack for the Artemis flights.
So the core stage is obviously horizontal. It's on the barge. It's going to roll out of the barge. It's going to go into what we call the transfer aisle, right? A long, you've probably seen it. It's a long hallway, if you will, where we can move big pieces of rockets along and then go vertical, where we literally tilt it vertical. Then we're going to go into a high bay 3, where we're going to set them down on these segments. So obviously I skipped over the boosters. First thing to come in, ML, right, on the crawler. It comes in, we establish the axis, we got the platforms down. We get the boosters one by one, we start stacking the segments. Then the boosters are standing there, left hand, right hand, are ready for a core stage. Then the core stage goes vertical and we sit it down on the booster for a detach point. And now we have the beginnings of an awesome rocket. Then we bring in the upper stage and we obviously go up and over, we call it, where we go up into the high bay and across into the high bay and down on the stack. And you can definitely see that in the Artemis I, high-speed videos.
This week was the 25th anniversary of the launch of NASA's Chandra X-ray Observatory, and in commemoration, NASA has released 25 exclusive images of what Chandra has been able to observe. The newly released images show popular astronomy objects through the eyes of Chandra. These include the Crab and Orion Nebula, the Pillars of Creation, the center of the Milky Way galaxy, and even Jupiter. Now, it's worth mentioning that many of these pictures are actually composite images where it's not just Chandra's data, but also data combined from other telescopes like Spitzer, James Webb, or Hubble, among others. This combining of information from multiple different areas of the electromagnetic spectrum is precisely what's allowed scientists to discover things that wouldn't be visible otherwise. For example, in the Orion Nebula image, teams have combined X-ray data from Chandra with a view of the nebula in infrared wavelengths from James Webb. While Webb's image allows us to see the plasma and the clouds of gas that make up the nebula, Chandra's view allows us to see between all of that and pinpoint where exactly new stars are being born within the nebula. And just like this, there are countless other examples where Chandra's unique and precise X-ray vision has been able to identify key events in space. Now, this telescope actually came very close to not being able to operate at all. During its launch in 1999 on board Space Shuttle Columbia, the mission almost missed its orbit, something that we covered on our recent video about some of the most important close calls of the Space Shuttle program. But as troubled as its start was, the telescope has been running mostly fine since then, but with some obvious degradation over the years from its use and stay in space. Now, this has led NASA to consider canceling operations of the telescope even when it's still active and working. In previous episodes, we've talked about the upcoming NASA budget proposals and how the agency is proposing to cut funding in the near and long term for Chandra and eventually phase out its activities. This is a result of further budget constraints within NASA's science programs that in recent years have affected a number of missions. While in recent weeks, some members of Congress have actually requested NASA to reconsider this decision, on the other hand, NASA's budget proposals for the upcoming fiscal year aren't looking so great, which could mean NASA may actually go through with it and pull the plug on Chandra. So while the agency and all of us are celebrating Chandra's 25th anniversary, it sure is ironic and a little sad that its days may already be numbered. NASA's Perseverance rover may have found intriguing evidence pointing to the existence of life on Mars at some point in history. The evidence comes from a rock that Perseverance analyzed just in the last week. The rock, nicknamed Shayava Falls, contains organic compounds within it with spots that point to chemical reactions that could have been used as an energy source by microbial life. The rock's location is also in a former river delta, which means water was likely present at some point near or within the rock. What intrigued scientists the most is the presence of the white spots within the rock. Similar spots on rocks here on Earth often point to biological activity taking energy from the chemical reactions that create said spots on the rock. So of course, finding organic compounds on this Martian rock that are close to these spots really makes one think that perhaps in the past, life may have been within it. But that's not all that was found on this rock. Teams also found crystals of olivine, which is a mineral that normally forms from magma. This means that the rock may have originated from a volcano further up the river that created the delta where Perseverance is currently located. It then was deposited down in the delta through erosion and the river's water currents. Now, the presence of olivine introduces another potential explanation for the spots that doesn't involve the existence of life. Under this explanation, the organic compounds could have been brought to the rock via other methods, so life may not have needed to be present. And this is why, while at first look things can look really exciting, more experiments are always needed to fully confirm something, especially something as important as life on another planet. In fact, the teams have exhausted pretty much every potential way to study this rock with Perseverance's instruments, and have taken a sample of it to be returned to Earth on the upcoming Mars sample return mission. That way, labs on Earth will be able to even further examine the rock and compare it to other rocks on Earth and other samples that Perseverance has captured or will capture in the future. And now let's take a quick glimpse at some other stories across space. This week, ABL Space Systems announced that it suffered the loss of its RS-1 rocket while on the pad in Kodiak, Alaska. The company made the announcement via social media, saying that after a pre-flight static fire test, quote, a residual pad fire caused irrecoverable damage to RS-1. This follows a previous issue that took place back in March, which the company never fully explained in detail, that had delayed testing of this rocket even further. ABL flew its first RS-1 rocket back in January 2023, and it resulted in a launch failure just a few seconds into flight, with the rocket coming back down on the pad and damaging the surrounding area. Thanks to our friend Harry Stranger and satellite imagery from Planet, it appears that this latest incident may have also caused damage to the pad. As we can see, there's a dark patch on the ground that wasn't there just a few days prior, and also what appears to be burned grass south of the complex. If there is indeed a lot of damage at the site, it'll remain to be seen whether ABL can quickly send out another rocket to this pad or not. This week, NASA announced that it has selected SpaceX to launch NOAA's JPSS-4 satellite. JPSS, which stands for Joint Polar Satellite System, is a constellation of multiple Earth observation satellites that provide detailed, high-resolution data about the Earth's climate. This, combined with the data from other observation satellites in geostationary orbit, allows scientists to build forecast models and predict the weather, as well as observe the Earth's changing climate with incredible detail. This satellite will be the fourth to be built and launched as part of this satellite constellation, with a fifth, JPSS-3, set to be built and launched early in the next decade. JPSS-4 is currently under construction, and with this launch contract in place, it'll hopefully launch on board a Falcon 9 rocket from Vandenberg no earlier than 2027. Blue Origin has announced the passengers for the next human flight of its New Shepard rocket. On board will be Ephraim Rabin, Nicolina Elric, Eugene Grin, Rob Furl, Carson Kitchen, and Iman Jahangir. The mission will also be the first time a NASA-funded researcher will be flying with their payload on a suborbital rocket. That researcher is Rob Furl, who will be conducting experiments on what sort of biological changes take place in organisms under different conditions of gravity. The tests will take place with different samples activated during different phases of New Shepard's flight, while on the ground, during 0G, right when 0G ends but before landing, and then back on the ground. These samples will later then be analyzed for changes in gene expression of the plants being used for the experiment. It's opportunities like this that could enable other future researchers to fly in short suborbital trips to perform similar short and simple experiments that wouldn't need a more expensive orbital flight to, say, the ISS or any other future orbital station. All of this comes just as the company recently rolled the forward module of a New Glenn booster out from the factory to its launch pad in Florida. The company's still preparing for the debut flight of this rocket, but moves like these are just another sign that things are moving in the right direction. Get it? Because it's going to the pad and all, so it's going in the right direction. Now let's take a look at the space traffic this week, which unfortunately featured no launches at all. This week we were hoping for a return to flight of SpaceX's Falcon 9 rocket, but unfortunately that didn't happen. But the good news is that just yesterday, SpaceX did confirm that Falcon 9 will indeed be returning to flight, and it appears the FAA has cleared the rocket for launch. The company also shared an update on what teams found to have been the cause of the failure of the Starlink Group 9-3 mission, which eventually grounded Falcon 9. According to the update, quote, during the first burn of Falcon 9's second stage engine, a liquid oxygen leak developed within the insulation around the upper stage engine. The cause of the leak was identified as a crack in a sense line for a pressure sensor attached to the vehicle's oxygen system. This line cracked due to fatigue caused by high loading from engine vibration and looseness in the clamp that normally constrains the line. The update says that this didn't impede the normal operation of the engine during its first burn, but the continued leak of oxygen during the following coast phase resulted in excessive cooling of engine components. This prevented a proper burn of the propellants within the engine, and it experienced a hard start. Going forward, SpaceX says it's removing the sense line and sensor from the second stage and have actually tested this fix on future second stages. In fact, we noticed the resumption of testing of Falcon second stages during the last week thanks to our McGregor 24/7 livestream. With that investigation out of the way and this fix in place, SpaceX is gearing up for a return to flight as soon as this weekend with, of course, a Starlink launch. The mission, Starlink Group 10-9, is set to take place from Launch Complex 39A on July 27th within a 4-hour window that opens at 4:21 UTC. If that goes well, SpaceX will then try to launch 2 Starlink missions back-to-back. The first one would take place from Space Launch Complex 40 within a 4-hour launch window that opens on July 28th at 4:13 UTC. The second one would occur from Vandenberg with a set of direct-to-cell Starlink satellites on board. The 4-hour launch window for that mission would open on July 28th at 7:24 UTC. Towards the end of the month, we'll have the launch of an Atlas V rocket from ULA carrying the USSF-51 mission for the U.S. Space Force. This mission will be the rocket's final mission for the U.S. Department of Defense, as future military missions will be performed by ULA's Vulcan rocket. The launch will take place from Florida within a 5-hour launch window that opens on July 30th at 10:45 UTC. Rocket Lab's next Electron rocket is also set to launch next week on the mission called Owl for One, One for Owl. The mission, taking place from the company's launch site in New Zealand, is set to lift off during a launch window that opens on July 30th at 16:15 UTC. And that's your weekly update of spaceflight news. I'm Elysia Segal for NSF, and I'll see you all again next week to recap this week in spaceflight.